Hello guys, welcome once again to another tutorial session on Python for bioinformatics. And in today's video, I'm going to show you how you can calculate the GC content of sequences when they are in multiple FASTA files. Now, in situations where you have sequences which are not all in a single FASTA file, then you need to have a way of automating the process so that your code will be able to read each of these files and perform the activity for you. And this is where Python comes in. So we are going to use these two libraries here to help us calculate the GC content of sequences in several files. So we'll download these several files, use loops to read and calculate the GC content, and then save the result to a file so that we can access it outside Python. If you are new to this channel and you want to know how to install Python libraries, I'll leave a link in the description box to a video for you to watch and install your libraries. Let's hop right into it. So we first need to get our data. I already have the data sets downloaded here on my system. Okay, these are the data sets and these are faster formats. I will leave a link in the description box to the pages for you to download each of these data. Okay, so for the sake of beginners, I will just show you how you can download each of the data sets with just one example here. So if you should visit the link which will be in the description box for, let's say, one of them, this is what you are going to have. Okay, so on this page here, you now download it here. Please watch my first video on how to access FASTA files to get an understanding of this process. So you will download the data sets here. Check on complete record. Make sure your file is selected, and then in the format section you select FASTA. There are several formats, but we want the FASTA format, and then you create the file, and then you save the file with the appropriate name. So this case will be 5.521. Then you save it. I had it there, so it's asking for replacement. Okay. Before I proceed, let me say these genomes are from 5 different strains of Staphylococcus aureus bacteria species. So that's what we are going to use. So now let's proceed. So once you have your data downloaded, you have the libraries installed, you will now call the libraries into Python. So we say from bio import SeqIO, from bio.seq utils import GC. Then we call pandas, import pandas as PD. Then we call two additional models, import OS, import glob. Okay. The last two come packaged with Python, so you don't need to install them. We now specify the path to the files. Which directory are they stored in? That's what we give here. So file directory is equals to /home sequences. This is my path. Yours is likely to change, so you make sure you give the right path there. We now use this to get all the files into Python. So we say FASTA files is equals to glob.glob. Okay, it accepts string. So we put in a string, and in the string we have %s/star.fasta. And then we now specify the inputs, that's file directory. So the glob enables you to access files that has particular patterns that you have supplied. So in situations where maybe we had other files, then using the .fasta extension, only these files will be taken and then made available for us to use. Let's just check how the data is. So we notice we have .fasta extension for each of them here. So Python will now be specific to take only this one. Okay. Just in case we had other files, Python will be selective and pick only those that we supply in the glob function. And that's what we just did with the dot star. So with the star dot fasta, we can just check that we have the files by just checking how many there are. So learn faster files. We have 5 of them. Of course, we can query. So let's just check the first record. Okay, this is the first record. Since we are dealing with just 5 files, we can just print all of them as well. So let's just say print faster files to get all of them there. Okay, so this is how we do it. So we now have our files, we have our libraries imported. So it's now time to start the main activity. But because we have more than one, it means we have to use a code that will be able to process these files without having to rewrite the code again. And so for that, we use functions to do that. Functions allow you to perform an activity without having to rewrite the code again. All that you need to do is to call the function by its name. So we'll create our function here. So our function is to calculate the GC. So we say def calculate GC. Now we specify an argument which is faster. So this means whenever we call the GC, we also need to supply it with a file name so that processing will start. So beginning of the function, we first need to read the faster file. To be able to understand this line, please watch my first video on reading faster file. Link is in the description box. After you've read it, we now extract the sequence. Sequence is equal to seq obj.seq. Okay, we now calculate the GC contents, which is GC content is equals to GC equals to sequence. Okay, so we are calculating it on this sequence we've extracted. We will now want to round the GC content to 2 decimal places. So we say GC content is equals to round GC content. We specify the number of decimal places. We want to print the GC content on the screen. And at the same time, we will still want to know which of these files or which of these isolates is its GC content being printed. So we need to get a file name as well here. We are not interested in the 4 parts or the extension here, only this one. So how do we do it? We need to first strip them of those informations we don't need. So we say file name is equals to os.path.split faster. So this will split it into the directory and then the file name with its extension. So we have a list with 2 members. We want the last one here. So we say file name is equals to file name 1. We will still have to process it further to remove the dot faster. Okay, because we don't need it. So we will say file name is equals to file name dot strip faster. So then we now print the file name. We print the GC contents. So now we have our function prepared. Functions by default will not be executed unless you call them. So we will call them when we are doing the iteration here. So we'll use for loops to move across the list and get each of these files and then process it. And how do we do that? The for loop comes in. So we say for faster in faster files. Then we call the function calculate GC and we specify the FASTA. We run it and then see what comes. Hooray, we have the GC contents calculated. And then we also have the sample or the file name displayed so that we know that this value belongs to this and this. Okay. Of course, we are dealing with multiple sequence. You need to have a way of accessing the results. What we just did was to calculate and print on the screen, which we can improve by saving it to an output file for us to read or even send to our colleagues to also check it out. So in the next one, we are now going to perform this GC calculation again. But this time we will save it to a pandas data frame and then now place it in an output file. Okay, so let's do this. So first of all, I'll say pandas is a great library for organizing your data. Okay, so I will encourage you all to use pandas to handle your data set. It makes life so easy for you. So we will need two list objects. Okay, first, these are the objects that will contain the file names and then list objects that will contain the GC content. So we create them. So we say file names equals to this, GC content equals to empty list. These are the two. Okay, they are now empty. Then I will come again. Now we will change this function again here. We will recreate it again here. But this time we'll add some additional details. And what are the details we are going to add? Instead of printing, what we will do is that we will just say return file name and then GC contents. Why do we use return? Because we want to return this file. This is a function, so by default, values of variables can only exist within that environment here and cannot be accessed externally. So we'll use the return to kind of hand it over to the one who is calling it, loosely speaking. But we will still want to track the progress. So you can just say print GC content has been calculated, at least so that we know that our process was successful. Okay, so let's do it this way. Now we have this function calculated. We will now come back again, still the same loop here. But now let's look at something else. When we issue the for loop, so for faster and faster files, because we have this return here, that means we are going to be handed some value, which are 2. Okay, so we say file name GC content is equal to, and then we give the function name, which is calculate GC, and then we specify the faster. Okay, so once we have these two values, what do? We now place them in their respective lists. So file names dot append file name, and then GC contents dot append GC contents. Okay, so now we run it. So notice that we have some statements printed here. Okay, so this is a way to know that at least each of these has been computed for us. So this is how we do it. So let's check from the list we created whether the data set has been added. So we say learn file names, we have it there. Learn GC contents, we have it there. Okay, let's just check one of the records, the first record. So let's say file names, we have it there, and the GC contents, You have it there. Okay, so the first record for file name has its corresponding value in the first record in the GC content here. Of course, we did that also here as well. Okay, so we have it organized. So now that we have what we need, okay, to calculate, now that we have what we need to create the data frame, we now proceed to create an empty data frame first. Okay, so we say data frame is equals to pd.data frame. And then after creating it, we now add columns to it. So these columns are the file name and the GC content. So we say data frame file name is equals to file names. Then data frame what GC, let's just say GC content is equals to what GC content. So we run it. So it's been done, but we can just ensure that we have everything there by saying data frame dot ship. Okay, at least so that tells us there are some values in this particular data frame. So let's just query it. We just have, so the 5 here indicates the number of data points. The 2 here means columns. So we have rows and columns. So the 5 rows here will indicate the samples for us, and the 2 here indicates the columns we added here. So let's just print data frame, or let's just say data frame dot head. Okay, so notice it has given to us the file name and the GC contents nicely arranged for us. So this is how the data frame is. It's more like a table with your rows and your columns. Okay, so now we will save the file. Okay, so before you save it, specify where you want to save it. Okay, so to save it, I'll advise you save it in the same directory as this one. Okay, just so that you know where to look for, but you can also specify any other paths. So let's just say output file is equals to this directory here. Okay, and then we add another name slash, let's just say gc content.csv. Okay, so this becomes my output file. So in this directory there will be a file called gccontent.csv which has my results. Okay, so I have that output file. So now save the data frame using that output file. So I'll say data frame dot to CSV. Now specify the output file. In saving, this values here by default will be added 0, 1 to 4, but we don't need it. These are indexes. So we just say index is equals to false. Then we run it. So now it has been saved for us. So let's go and check it out and let's see where they are. Because I saved it in the same directory as where the sequence is, so we just go straight there and check. You should also do so with your data. So let's check. So we have the direction. So notice it has been created here for us. So let's open it and see how it is. So see how nicely it has been arranged for us. So if you had, let's say, thousands of genomes or sequences in different files, you don't have to do much. You just follow this instruction and you get it done. So from here, you can use any spreadsheet to open it. It's a CSV file. And then after opening, you can even send it as an attachment or maybe prepare reports or draw your graphs or do some other analysis using this file. Okay, so it's important you get to know these ones. So it's interesting how Python makes analysis easy for us as beginners. And I will encourage you to explore more features in Biopython to help you. I'll be making more videos on how to use Biopython to process bioinformatics data, and then so keep watching this channel for more of these goodies. Thanks for watching, and I'll see you in the next session. Goodbye.